Okay, so a function is basically a rule of association. It's a rule by which I will associate items from two different sets, which must satisfy these two conditions, such that it has to be defined for each element of the first set, and each element of the first set must be associated with only one element of the second set. So, if you look at this example, the first example right here, we have a set of children and a set of mothers. There are three children here. So we see that each child is associated with one of the mothers from the set of mothers. So the first condition is satisfied. And furthermore, each child only has one mother. The first child has a mother one as their mother. The third and second child have the second mother, mother two, as their mother. So that's a function. But what would be an example of, let's say, what would be a non-example, like something that's not a function? We can look at this picture here. So consider customers at a store. So let's say two people, like two guys walked into a store. They look through the available catalog of things and they realize that, well, the second customer, he thought that, I don't really need anything, so he didn't buy anything. And the first customer, he decided, well, I like both of the products that this store has to offer. I'll buy both of them. So what's the problem here? The problem is that it's not defined for all elements. The second customer doesn't buy anything. But this rule of association that we shall call a function requires each element of the first set to be related to someone, something, anything, at least one thing in the second set. That's the first condition. And the second condition tells us that it has to be associated with precisely one element in the second set. So the first problem is that customer two doesn't buy anything. The second problem is that the first customer one, buys two products. So that's another issue. It violates the second condition that I need to associate only one element of the second set with an element of the first set. So if we have this out of the way, um, we need some additional properties along with being a function. So we're not satisfied with a rule of association that's just a function. If we add a few more special properties, it becomes more useful to us. So the properties are surjectivity and injectivity. So when do we say that a function is surjective? So by surjectivity, I mean that each element of the second set is associated with at least one element for the first set. So if you look at this first example here, and if you look at the set of mothers, so if you are a mother, we understand that if you are a biological mother, you have at least one child, right? And that is true because here, mother one has child one as their child, mother two has two children, child two and child three as her children. So this satisfies the condition of surjectivity. And then what do we understand by injectivity? So by injectivity, I mean that, let's say the two elements in the first set, they are different. If so, the elements in the second set that these two will be associated with, or these two will be related to, they are also going to be different. Or an equivalent thing I could say is, if two elements from the first set, let's say those two are x and y, if x and y are such that they are related to the same element in the second set, then it must mean that these two elements, x and y, are actually the same. So simply put, if the elements are different, they're related to different elements. If they're related to the same element, then the elements are same. Yeah, that's pretty much it. So here, in this picture over here, figure 1.2, we see a set of students and a set of ID numbers. So each student has one unique student ID associated with them, right? So if the two students here, student one and student two, they are different, their ID numbers must also be different. Two different students cannot have the same ID. So this is an example of an injective function, right? And now, if a function has both these properties, if a function is both injective and surjective, we call it bijective or bijectivity. Bijectivity is the property that a function is both injective and surjective.